To the teacher?
Yeah, our teacher, our colleague, it's Greek.
Greg?
Greg, yeah.
Yeah.
Will you send him a message?
Let me see if he's sent anything back, but
Probably not. But I believe he will show up
yeah.
before the last question. He will show up.
Yeah, before the last question.
Give me a second.
Okay.
Okay. Yeah.
I'm going to go ahead and open up my quiz. Ooh, open up the spreadsheets and stuff too.
Yep.
Okay, I think I got everything open.
¿Dónde? Sí. Sorry. I'm ready.
Okay.
So do we start the quiz?
Yeah, go ahead and open. There's a bunch of stuff, data files that we have to open up and all that. So go ahead and start opening all that stuff up.
Okay. Super duper. Got one. Use it, exercise and direct flight costs. Okay. Mm-hmm. Okie dokie. Listo.
Okay, you ready for number 2? Are you guys ready?
Yes.
Could you do number 1?
Yeah, number 1 is, are you participating?
Okay, this is the
I hope you are. So number 2, given the 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of the confidence interval? I'm going to say we are 90% confident that the true mean heart rate is between 45 and 105.
I agree. 90% confident. I think we always use confident, not chance or of all people.
Yeah.
And we start by saying we are.
Yes.
We are.
We are 90% confident.
Not there is. Okay.
Great. Okay. The second says, use the following information to answer the next 2 questions. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no go, ¿cómo se dice? Stimulus of males differ from, is that Greg?
Yeah.
Nope. Sorry, guys. You got me during my work time, and I had to pretend to be responsible for a while.
Okay. Well, go ahead and open up everything. We're just getting started.
Now, this is a review of everything we did, right?
Yep.
Yeah.
Yes.
I probably shouldn't talk in mocking, joking American bad English. It's too hard to understand.
This is really good because I didn't want to learn something new.
You just wanted
I didn't want to either. Okay. Have you guys been on for a little bit? I saw your email, but I had to run into a meeting, so.
That's fine.
Yeah, we didn't go like too far because you were. We couldn't do without you.
Oh, I'm so important. Oh, see, you make me feel so special.
But we just answered number 1.
And number 2.
And
I was about to answer number 3, but you can take it.
okay, hold up. Okay, 15. We're at 15, right? 15 meeting questions.
Yep.
Okay. start the quiz. Okay. Number one, number two. Oh, number two is not the same. Okay. Give a 90% confidence interval for mean heart rate. Which of the following is the best interpretation of the confidence interval? I got this one wrong the first time I took it. This was on the quiz last Saturday or something. So, or whenever, one of the quizzes. Is it number two?
Yep.
Yes. Woo.
Okay, I'm on fire. I got one right. Don't stop me now.
I know.
Okay. Number three, the researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether a confidence interval would be reliable, they create QQ plots of both random samples to see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Our QQ plots last time, right?
We did.
Yes.
Why did we mess up again? What did you say about that, Edgar?
They have to be is from the least to the most, right?
Ascendant order.
Yes.
Oh, that makes sense. So we have to put them in order first.
Right.
Yeah.
Okay. Do you remember how to do that?
Yeah.
Yes.
Yeah.
I don't know how
Yes.
to do that.
Thank you, Edgar.
How? Okay. So what do I do to put things in order?
If you sort it'll ask you from least to greatest or from greatest to least, and you want to go least to greatest.
So where's the sort button? Is it under format cells?
Yeah. No, actually, I think it's over on. Let me see.
Under page layout, insert, data, review,
The
view.
mouse. I use the mouse. Right click and just
Oh,
choose.
sort. Perfect.
Sort. Yeah.
Sort, small, so we do smallest to largest, right?
Yep.
Okay, done.
Yes.
Fantastic. Okay, so this says
Yep.
they would be reliable to determine construct a confidence interval. No, it needs to check all the data combined, right?
I think this one you just have to analyze the data and choose one of the answers here.
Yeah. I put yes. The distribution of the means of each sample is normal since the data have been determined to be normal.
You know, you're right, because we can infer that it's from that the distribution is normal.
Because
Okay.
it says they ran QQ plots for both random samples to see if they were approximately normal.
It's because it has been determined. How do I read this?
Determined.
Determined. It has been determined. If we see the information there, they say that.
Yeah, it says the QQ plots of both random samples and see that they are approximately normal. So they ran plots and they're approximately normal.
Yeah, I think that's true. Number three, that makes sense. So the third one, yeah.
Okay, number 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
For mean when
I chose the second. Confidence interval for mu
I don't know this.
Sigma is unknown.
So the experiment is whether the reaction time to go or no-go stimulus of males differed from that of females, biological females. Just kidding. The researchers randomly selected 20 females and 15 males to participate. So this, not related.
Right.
They're different. Okay. To go, no-go stimulus requires, are they talking, by the way, do you think this means in terms of like red light, green light type stuff?
Yep.
Okay. required the student to respond to a particular stimulus and not to respond to other stimuli. Okay. Okay.
One confidence interval for the difference of means using independent samples? No.
So this one, it has to be just each sample normal since. Oh, wait. So confidence interval for difference of means using independent samples.
That's what I got.
That's I think it's number 3 because it's 2 unrelated groups and it's the difference of their means that we're determining. And they're independent samples, like they're not dependent on each other.
Right.
Right? Okay. Wait, I guess I said that twice. Okay, that's what I think it is.
Well, I chose the second because they are talking about confidence intervals in the subject there, and we don't know the mu of the population, and the sigma is unknown in there.
That makes a lot of sense too.
The standard deviation?
Because they are talking about confidence interval in this part.
Interval.
To determine whether the confidence interval will be reliable, they created key plots of both random samples.
Confidence interval.
What is so of the 4 types of confidence intervals listed below, which is the most appropriate? It's the most appropriate.
It's about confidence interval, no?
Sigma known. All right. Sigma unknown. Two means inference for two means inference for several
Okay.
means.
If one it's not right, the other one will be right. We have chances to do the quiz.
A ver.
But
Okay. I'm going to try,
the researchers.
because in order to determine the confidence interval, I honestly think that number 3 would make the most sense, because that's what's different between this experiment and other experiments, right?
And then they want to determine if the difference of the means is significant. So, history.
So there's no way on this one that we could compare the men to the women if we were just doing one sample, which is the second one down, which is the confidence interval for mu when sigma is unknown.
That's only one sample?
That's only one sample. This
Okay.
is 2. So it's either got to be paired or independent.
And we know that it's not dependent because
Right.
they're not spouses or siblings
Right.
or whatever. So
Right.
okay.
we choose the third one, no?
Yeah, the
Yeah.
third one.
Keep going. Question 5. I will try to read. Okay, I
Right.
hope you understand.
We can read ourselves. Just do your best.
A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is about to be 3,402.08, and the 4,000 142.75. Which of the following would produce confidence interval with a smaller margin of error than this 95% confident interval?
I think is the last one. Obtain the balances of 90 bank customers rather than 30. There is a rule with that if you increase the number,
If you increase n,
then the margin of error will decrease, right?
Yeah, I choose this one because if you increase 99%, it doesn't change a lot. But if you increase the n,
yes, the
the
number
large,
of samples.
the number
Yes.
of samples, this makes a lot of difference.
Great.
I agree.
Super agree.
Okay.
Okay, I'll read this one. This factory makes propeller. See, propeller.
Propeller.
Propeller drive shafts. Shafts.
The tongue twister.
Propeller drive shaft for ships.
Yep.
Just watch yourself, Quiel. So, do you know what a propeller is?
Propeller?
Do you know what a propeller is?
No.
Okay, the verb propel means to move forward, to move you forward. Okay, so a propeller, we call it a prop, is a long time ago on the front of a plane or the back of a boat. Right,
Okay.
or it's like a fan, but on the back of a boat. That's a propeller. So the drive shaft is the part where when it spins, that goes to something else, the engine.
Okay.
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 So the engine turns and a drive shaft. Okay, for ships.
Okay.
This is the propeller.
Las hélices o las.
Hélices.
Sí.
Well, what's the verb then?
No hay un verbo.
Elizar.
No sé.
Okay.
No hay.
Echar pa'lante.
Sí,
Okay.
algo así. Okay.
Look at all those propeller places by you up there.
Yep. Lots.
Did you see that? The map showed all the propeller places by you?
Yep.
Okay. Okay, keep going.
Do you know about the other student?
Adner?
Edgar or Edner? Okay, Edner.
Adner.
Yeah. What about him?
Do you know anything about him? Did he give up or?
Well, I think he got confused with the time change. Or that he can't be at that time. I'm not sure. I haven't been able to work it out with him. But the teacher said if he's having trouble meeting, that he should join another group.
Maybe he did that. Maybe.
Yeah, I don't know.
There they can hear him.
Maybe.
Yeah.
I hope so.
Okay, let's go with our propellers.
Who is reading this? Okay, we have a propeller now. Okay.
A quality assurance engineer at the factory needs to estimate the true mean length of the shafts.
I love how he says that.
She randomly selects 4 drive shafts made of the factory, measures their length, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Put your answer for the margin of error, lower bound and upper bound.
Why is it?
Error for these 95%.
Why is this hard for me now when it shouldn't be?
So it's going to be that 1.96, which is the z-score for the 95, times the standard deviation over the sample size.
Which
Square root of sample size.
which the square root of
Of the sample size,
the
right?
sample size.
Okay, so 1.96 times the standard
times-
deviation,
which is 2
Yeah.
millimeters,
okay, divided by,
the
By
square
2.
root of the sample size, and it says she randomly selects 4 drive shafts.
oh, it's
4.
Then,
Yep.
then it will be
So the square
2.
root of 4 is 2. 2 over 2 is 1. So that would mean that
The answer will be
going to
the-
be 1,000 plus or minus 1.96.
okay, hold on. Do you divide 2 by 2 and then multiply by 1.96? Or do you
Yeah.
multiply
Yes.
1.96? Yes?
Yes.
Yes.
it will be 1.96. The answer, isn't it?
Yep.
Yeah, 1.96.
We can say that.
So then you have to add that and subtract that from 1,000 millimeters to get your upper and lower bounds.
Okay.
Yeah.
I don't have my calculator.
Use the brain.
No way.
It's hard. That's super hard.
So the margin of error is 1.96, correct?
Yep.
And our lower bound is 998.4, and our upper bound,
998.04, and the
yep,
1,196.
Yep.
0.96.
0.96.
So what did you get for the margin of error?
1.96.
Oh, the confidence level?
Yeah, it's no.
No. The confidence interval is that times 2. No, it's not.
Yeah.
It's 1.96.
It will be the same, but yeah.
And the lower bound?
The lower will be 998.04.
9.04. Okay.
Oh, the next one's hard.
I know.
No, then the next one, I think it will use the formula of n. The sample size equal. Just use this formula and you get everything done.
I forgot about that one.
Yeah.
Oh, I'm gonna have
What's
to
the-
write that one down.
What's the formula?
The formula n equal that z with something up the times standard deviation divided by m and all these things
M
squared.
being the margin of error.
Yeah.
Okay. Yeah. So, okay. Give me a sec.
Did you get it?
I got it.
Okay. Say that one more time.
Z times the standard deviation over M squared. Not M
M.
squared, but the whole thing squared.
Oh,
What is the standard deviation?
okay. So
Oh,
Z is 1.96, right?
Yes.
Yes.
times 0.01 over 0.0001 squared, right? So what do I do first? The multiplication or the division?
Multiplication.
You
1.9.
multiply, then divide, then square.
So what is M? What is M?
Oh, it's
Margin of error.
the last
No,
thing
M,
will be to square. The last thing will be to square, but if you want to divide first, then multiply will be the same.
Yeah.
So I got
The last
384 point, what?
Yeah, I point one.
384.16?
No, it's not point. Is it point?
Well,
No, it's not. It's like the entire number, 38,416. This is what
okay, see, I didn't get that, so I got somewhere wrong. Okay, so let's do 1.96 times 0.01 divided by
38,000.
Yeah,
416.
416.
oh, it's 196. I get 1. Okay, okay.
Okay.
38,416.
Yes. Oh.
Okay, number 9. This uses
Yikes. So you said it was 38416.
Yep. You can round it to 0 decimal places, okay?
Is it? We're supposed to? Oh, so it's 0.00, right?
No, you don't have to do it. I'm just kidding. It's not asking.
he's joking because there are no decimal places. It's 38,416.
Okay.
Okay.
The mean. Oh, we all ready?
Yeah.
Okay.
Yep.
I'll read this one if you want. The mean area of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses, HO and HA, are for mu are. So the null is,
Equal.
well, they think they're smaller. So it is the last one.
Yes.
I
New
choose,
order.
I choose the last one, but
I do too.
I don't know really if it's right.
It is.
Well, none of us really know.
It is.
This sounds like something that would happen in Brazil.
I should do this for my trash can. They just gave me a new trash can and it doesn't hold as much as the old trash can. And I swear they keep telling me, oh no, it's this size, but I want to do I should do that as our experiment for the end of class.
You'd have to test all of them on the street.
Yep.
Excuse me, can I test the volume of your trash can? How do you propose to test the volume of a trash can? Smarty
Filling it with water. I don't know.
That sounds like a party.
Or like filling it with trash, like 13-gallon trash bags. How many 13-gallon trash bags can you put in a 20-gallon?
Yeah, that would be fun.
I think you should calculate the mean and it is the standard deviation known or
Right,
unknown?
standard deviation.
Right? You guys know we have to do this, right? Do a project.
We do?
Yes.
Do we?
Yeah.
Oh yeah, I'm dead.
You're dead. We'll have to figure that out.
Okay, number 11, in a statistical test of hypothesis, we say we reject the null hypothesis with a level of significance alpha if
The p-value is less than alpha.
Agree.
We reject the null when the p-value is less. Correct.
yes.
Okay, is it my turn to read?
Yep.
Question
You
12,
have
1 point. Okay, a group of statistics students wants to determine,
Determine.
yeah, this is hard for me. Determine
It's okay.
if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAS
GPAs.
from GPAs from anonymous
Anonymous.
Yeah.
anonymous random sample of size 15 from each of the 4 different apartment buildings. The data for each apartment buildings are bell-shaped with no outliers, and the sample variances are near equal. Can they use an ANOVA hypothesis test to answer their question?
No.
Why no?
I think the rule is that data should be right skew, something like that.
I think it could, so it can't be a normal distribution. It has to be right skewed. I think you're right. Yes. No, they do not have the true standard deviations. No, they don't have enough data. No, they need a total of 60 GPA. No, is enough for that.
No,
Because the is it the T? Is that what you're for the ANOVA? What's the S?
F, as in Frank.
That's right. It's the F. Well, the F is far right, but that's what the ANOVA wants to determine, right?
Let me read this.
for the ANOVA test
Each apartment building, their bell-shaped
area in the right tail.
Yeah, so if it's bell-shaped and the sample variances are near equal, it could be ANOVA.
But if it's bell-shaped, means it will be in the both 2 tails.
Yes, the tails.
And ANOVA, it's not 2 tails.
No, it's one tail, right skewed.
1 tail.
You're right. It's only one tail.
But my question is, bell-shaped is 2 tail?
Yes, they'll say this. Well,
It could be one-tailed.
It could be one tail, depending on what your hypothesis, what you want to determine.
So what are we wanting to determine in this?
Oh, okay. Then I chose this, the third one. Yes, it's enough that the data for each apartment building are bell-shaped with no outliers, and the sample variance are nearly equal. But I probably guessed this one. But what is outliers? What does
Those are
it mean?
the data that's way out in left field. It's not
Okay. Then this is not.
closed in.
Okay. With no outliers, and that means it's closed. The first one, we can choose this one. The second, I can't choose this one because I think we have enough data in there. And we only have the third one and the last one to choose.
Okay, requirements of ANOVA. There are only two. The data are normally distributed in each group.
Bell-shaped curve.
We check this by creating a QQ plot. The variances are equal for each group.
Yep.
The requirement is checked by examining the variances. That's right, and we're doing that. So bell-shaped and the variances are equal. So it sounds like yes.
Sounds like yes.
But hold on a sec, because it says the ANOVA test for equality has several means, but so it allows us to compare the means for several groups in one hypothesis test.
Yeah.
Okay.
So when in the hypothesis, you're saying all of the means are equal or they are not.
So so let's see, because what's happening is the sample variances are nearly equal. So my guess is we're not measuring something that's going to, well, let's see.
But
The
because
rule
they're
is-
nearly equal, we can use the ANOVA, and that's what they're asking us. Can we use the ANOVA?
Okay. Remember, so the variance is, the rule is, if the largest variance is less than or equal to 4 times the smallest variance, and absolutely it's going to be fit within that, then we conclude that the variances are equal. Okay, so I'd say number 3.
I agree.
Number 3.
All righty, let's move on. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is the average survival time after diagnosis is the same for new treatment as for the standard treatment. In an early trial, she tries the new treatment on 3 suspects. Why are
Subjects.
they? Oh, subjects. I thought they were said suspects. I was like, why are these
A
suspects?
suspect is when a crime has been committed and the person you think might have done it, that's a suspect. So
Subject.
that's
okay.
funny.
Thank you.
Yeah, that's my dyslexia thrown in there. Okay, who have average survival times after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at a 0.05 significant level. Consequently, she rejects the null hypothesis. In future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has committed an error.
A big error.
New treatment does not increase.
Which kind of error?
Type 1 error is wherever we reject a true null hypothesis, well, what? And level of significance is the probability of, never mind. I don't have
Oh,
that.
it's like if you reject the null hypothesis while you should have not rejected it. It's error type 1.
Yep, committed a type 1 error.
Error. Okay, error.
Error.
What is the
Error.
type 2?
Error.
It's an error.
Yeah. Error.
Error. Error. I can say that, but okay, it's okay.
Error.
Error.
So the
Don't
type
know
one-
you are.
The type 1 error is when you reject the null, but then in future studies it's determined that that was incorrect.
Yep.
Okay, wonderful. Okay,
Number 2 is you don't reject, you shouldn't reject. Right?
we should not have rejected the null.
I choose the first one for me.
Okay,
Yes. So
okay, number 14. Is it, whose turn is it? Yours, Edgar?
Yes.
Okay.
If the level of significance is made very small, thereby making the probability of committing a type 1 error. I was confused.
Error.
Very small. What happens to the probability of committing a type 2 error? If the legal significance,
I don't think there's a relationship, because that's just depends on your choice, right?
It depends on if you reject or don't reject.
So the relationship between the two probabilities depends on how the study is set up, maybe.
When I was studying before, I found out that if you reduce the type 2 error,
Trap is right there. It's got blood all over it.
you increase the probability of committing type error 1.
No. So it's the opposite effect, right? Choosing a very small level of significance, the probability of committing error. At the same time, you increase the probability of committing a type 2 error, looks at.
Yeah, what I read was like,
Do what you want with it, but if it comes back.
If you reduce the type 2 error, okay, that one, you increase type 1 error. Contrary, I don't know if that applies.
I think so. It should apply.
And my guess is number 1, but we can discuss this.
Yes, I think so. I think the first one. If we decrease the probability of type 1 error, we increase the probability of committing a type 2 error.
For some reason, this seems like it's a trap. It seems like they're trying, you know.
Okay, so my notes on it, it says we never accept the, no, we reject it. Okay, probability of type 1 error, probability of type 2 error. When one probability goes up, the other goes down.
Okay, and vice versa.
Yes.
Okay.
I would imagine so.
Yours.
And the researcher has to decide which one is greater consequence, a type 1 or a type 2.
So that's the researcher, but the probability would increase or decrease based on it. Okay, that makes sense.
The probability goes up.
Type 1 error is when we reject and we shouldn't reject, right?
Right.
Yes.
So type 2 is when we don't reject and we
should have.
Yep.
So I think it's the first one.
Okay. Okay. Number 15, my turn. The nicotine content in cigarettes, you guys know, what nicotine is, right?
Yes.
It's the same. It's no nicotina. It's
okay.
It's what makes you addicted to cigarettes. It's the bad stuff in cigarettes.
Yeah. And in my mission, it was in Portugal. We had a lot of people smoking there, and we had to help them stop smoking in 15 days. We had a program.
Really?
That in my mission. But today I'm looking for finding the data, the information about that. I can't find. I'm asking everyone to send me, but no one can send.
That can be part of your final.
Yeah.
Your final project.
What we did there was to try in 15 days to take out all the nicotine inside the body of someone. And if you don't have any nicotine in your body, you don't have desire to smoke. But if the lesser you have inside, the more smoke you need. Your body is asking.
Yeah.
Do you understand?
Right,
have a
because your
list,
body already has a dependence on it. Yeah.
but if we have nothing, nothing will be asked.
Interesting. Okay, I'll read this. The nicotine content in cigarettes of a certain brand is normally distributed with the mean in milligrams mu and a known standard deviation of 0.17. Wait, did I read mu wrong? That's mu, right? I did.
Yep.
The brand advertises that the mean nicotine content of its cigarettes is 1.5. Okay, so 1.5. But measurements on random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? This is the hypothesis test. The null hypothesis is mu equals 1.5, and the alternative equals mu is greater than 1.5. Okay, at the 1.5 level, I mean the 0.05 level of significance, you could conclude, you conclude that you should, okay, so let's do this. 1.96 times 0.17 over
We have
Which one are you doing? Okay, so are we doing, is this a, we know
what
this
test is this?
deviation, right?
This is to determine.
Are you trying to calculate the p-value?
We need to get the p-value so
Yep.
we can then, we need the p-value so we can determine if it's higher or lower than the level of significance.
So is this a Z test, a T test, or an F test?
See,
We are not comparing two different groups. I think it's just a Z test because it's just one brand,
Right?
and we're not comparing to anything else, and we're comparing to the null, which is 1.5, which is advertised. So I think it's a Z test. We get the p-value and determine that.
Okay, so we do X bar, which is 1.53 minus the mu of the mu, which is
1.5 or 1.53? Wait. Which?
1.5, right?
Okay.
Okay, we are trying to calculate the Z-score right now.
Yeah, because it says the mean nicotine content of its cigarettes is 1.5, so 1.5 over the standard deviation, which is 0.17 over the square root of the sample size of 100, right? Is everybody getting that?
I'm trying to find the formula.
Okay. What's the? You said X bar minus 1.5 over the square root of 100.
X bar minus mu. So X bar minus mu
Uh-huh.
over the standard deviation over the square root of n is the score.
Oh, so the standard deviation over?
Yep, 0.17.
So then we
divided
got one. Oh, right. Oh my gosh, we know this.
So X is 1.53 minus 1.96.
It will be a standard deviation over the square root of n.
The standard deviation is, do we have
0.17.
Oh, yes.
So is it 0.03 divided by 0.017?
Yes.
Right?
Yep.
1.76.
1.76 is Z-score, and we're going to stick that in our handy dandy little,
Normal will we use the normal probability?
we'll use the normal probability. And we put it in our z-score, 1.76.
We don't reject.
So you got an area of 0.82082.
We fail to reject.
So what's the p-value? I don't have the applet open. What's the p-value?
I got 0.082, but I'm using the other one, so maybe I should open the other one. Just to make sure so we don't get it wrong.
Okay, what's the t-score?
The z-score.
We're looking for the z-score.
Okay, the z-score. What is the z-score?
0.0784 is what the p-value is. Well, no, sorry. What are we doing? What are we doing? We're doing what's our hypothesis? It's less than?
Less than.
0.392.
We failed to reject.
Oh, see, you have to
Smaller
use
than it. Okay, so I got 0.039. Is that what you got?
03.
Oh, wait a minute. It's a greater than, right?
It's great.
Yep,
we reject.
right.
No, it's greater than
Okay,
5.
We don't reject. We fail to reject.
Because it is smaller than 0.05, right?
Yep.
Yeah.
Okay.
No, it's more. It's bigger.
0.039?
039 is not.
039 is less than.
Less. Okay.
So we. Oh.
But okay, I messed here. What is the z-score?
1.76.
Okay.
Oh, this one was easy. Oh, but anywhere.
Oh my gosh.
Did you use the normal probability applet?
Yes.
Yes.
But it okay, I have the z-score here, 1.76.
1.7.
The z-score.
The z-score.
Yep. I use 1.76.
And the
area
is 0.07.
Yep, because you have it clicked on both sides. Just click on the one side on the right.
So I put that one in the other applet, and it gave me a 0.40 area.
Oh, it will be point
So make sure you use the right applet.
Okay, but it's
I mean,
they're
it's close,
up.
but not really.
They are close, but okay. Good.
Okay. Whose turn is it next? Is it mine?
So let's go back.
Mine.
So we said
for mine.
That was 15, right?
That was
15. So we failed to reject the no, right? Okay.
Why?
We failed to.
No, we reject. We reject.
We do
the alternative.
Reject.
We reject the null. You never reject the alternative.
It was less than the level of significance.
Yep.
What?
So,
What?
so it's number four. Number four, right? We reject the null hypothesis.
Yes. Number 4.
Okay.
¿Qué hacen?
Reject the null hypothesis. Okay. Question 16. Probably it's my turn.
Bueno, ya, vayan allá afuera porque... Sí, vayan afuera.
Ya, niño travieso, vete ya.
Mira.
Maybe I'm reading this one because it's short.
¿De
Okay.
niños traviesos?
¿Quién llama? ¿Quién es?
Jaime.
No,
Me llama.
Hola.
compañeros de la
Hola.
escuela.
Hola.
¿Qué pasó, papito?
Ya vayan a dormir, corran.
Ah, yo quiero ver.
Ya,
Look,
ahí está.
Mini Edgar. It's Mini Edgar.
Edgarcitos.
Mini Edgar.
Mini Edgar.
Mini Edgar. Edgar Jr.
Edgar Jr.
Vayan, corran.
Mami.
A su cuarto. Vayan. Adiós.
Ciao.
Corre, corre.
Okay. I'm going to read this one because it's shorter than the other. Okay.
Okay, you go.
Question 16. 1 point. You would like to look at the mean number of hours worked for wage per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistic procedure?
All right.
Okay.
I think it's a T-score. A paired, no, not paired sample, independent samples t-test. It's 100 of each, same. They're independent. You would like to look at the mean of hours worked for wages. But it's not a one sample t-test.
It's an ANOVA, right?
Two samples to test. They are independent.
Because
For
you want to
male-
see the difference.
Yep, you're right, Herman. Independent sample t-test.
Yes.
Okay. 16.
Just 2 samples.
And okay, we don't need this information, but they would be approximately normal because the sample size is large. But we don't
Yeah.
need this information now.
Nope, we don't.
Okay,
Wait,
I
wait, wait.
read on
Okay.
I'm just showing that I know something.
So proud of you.
an educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling?
It's the last one. It's number 4. Because what it's asking also is why are they dependent? And number 2 says the sister's academic achievement depends to some degree on her brother's. No. Has nothing to do with the achievement, has to do with the relationship. So number 4 says if you select a brother so as to compare his academic achievement to his sister.
Yes.
So the reason you're, yes, that's, so it's number 4,
Okay.
I think.
Dependent sample.
Yep,
Mhm.
dependent sampling.
And dependent sampling only has to do with the relationship. Meaning if you, the only reason you picked number 2 is because of the relationship with number 1.
Yeah.
Right.
So if you were to say, I picked boys who's, and then sisters that are older. Well, the relationship is they have to be older. Like they depend on the other one for it to actually work. So, okay.
Yeah, because you need to take brothers and sisters and sisters depend on the brothers, brothers depend on the sisters. Okay. I understand.
Well, they're just paired. It's like right and left arms
Yeah.
paired.
Right.
But
They're paired. Yeah.
another way to figure it out is in an independent sample. I mean, this can throw you off too, but in an independent sample, they can have different sample sizes.
Right.
So if it said, oh, we're going to do brothers and sisters, but they had 20 brothers and only 15 sisters, then they're not dependent on each other.
Oh, okay.
So just beware.
Okay.
Okay,
we are still
next question.
far away for finishing.
Okay, you have to open the file.
Yeah, we're going to use this for the next 4 questions. A soil scientist collected random soil samples from a field that measured dissolved organic carbon levels of each sample. The measurements are recorded in dissolved organic carbon. The researchers would like to construct a 95 confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed, which one is appropriate for this situation?
Soil scientists collected random soil samples from the field and measured the dissolved. Okay, so we have.
What should we do?
You have 20, n equals 20.
Yep.
Alpha is 0.05.
Mm-hmm.
Okay, so we only have 1 sample, or we have 21 samples copied.
20. Because the top one's the label. So, confidence interval for mu when when the
Standard deviation.
standard deviation, thank you, is unknown. Well, that's not true because we know the standard deviation. We can figure that out. Confidence interval for the difference of means using independent samples. No. Confidence interval for mu when standard deviation is known.
Are we using one sample t-test?
This would be a z-score because, oh yeah, this is a z-score. A t-test is comparing 2 different samples, from 2 different sample groups. Whether they're dependent or independent, that's what a t-test is for. We're not comparing the difference between 2 different groups. All we're determining here, so I think we are the confidence interval for mu when the standard deviation is known, because really simply we can determine the standard deviation. Does that make sense, you guys?
No.
Yes.
Okay, standard deviation. Is 4.325, or here, let me see. Not like it really matters, but
How did you calculate that?
Excel.
in Excel, see what it's not telling you when you have the standard deviation presented here, but we have the information and we can determine what the standard deviation is. It's when we don't have the information to determine the standard deviation.
Yeah.
Am I right?
Because you can determine the mean.
Oh, the mean is 13.193.
This will be the sample mean.
Mm-hmm.
Yeah.
The mean, see, that's just so anyone can determine that. Like, it wouldn't make sense to have a test for the standard deviation unknown when within 5 seconds you can have it. No one's that lazy. Like, what? That wouldn't make a sense to have that test. So we know what the standard deviation is. It's 4.362. the confidence interval for the difference of means, we don't have two different groups. So there's no need to be determining the difference between means. And the last one says that also the mean of differences. We don't have that either. We're trying to determine a confidence interval to say we are 95% confident that any samples from this field that are taken will fall within the standard, not standard deviation, the what is it? You know what I mean? Okay, so I think it's number 3. Please feel free to tell me your thoughts if you disagree. Totally cool.
32 questions.
What's that? Do you guys have any comments? You agree? Do you disagree? You fail to agree? You fail to disagree?
We failed to reject.
I have insufficient.
So you're saying that you failed to reject the null hypothesis. In other words, you think I'm right.
I have insufficient evidence to say that you are wrong. To say that you are.
Okay. Well, it looks like number 18 is going to be depending on me. Bad idea.
Okay, so I have a question.
Yes.
Is
Just one.
the information that we're getting, is it samples or is it the population?
We have samples. We don't have the population.
So we don't have the standard deviation for the population?
We don't.
The
Okay.
soil sample. Oh, these are samples. So the
Yeah,
standard
this-
deviation is for the samples.
Do we need the standard deviation for the population if we're going to figure a z-score? We can get the standard deviation for the sample, which is the S and not the sigma.
Okay. So I guess what you're asking then is, what is required for a z-score? Like what is the standard deviation? Is it a standard deviation for
The population or for the sample?
That's a great question. So let's find out.
I think it's for the population.
Mu when alpha is, when sigma is, what's it? This is alpha, no? Is unknown.
Alpha is unknown.
And this it would be if we would do like a t-score for this one.
I think
Okay. So
This is a little bit hard.
Yeah.
My guess is that it's number 1, confidence interval mu when sigma is unknown.
Okay, we can. Okay, if this is not right, we'll do the other one. Okay.
Gotcha.
hold on. So
Yeah, it's a little bit confused, but
I see what you're saying, because we were looking at the sample size as opposed to what the mean or the standard deviation is.
So do you guys
So
have
you
this
think that-
testing means flow chart?
Where did you find that?
It's in,
It's in the announcements.
Oh, I never read the announcement.
We can actually use this and another sheet of notes. So he said we can use this and another sheet of notes.
Okay,
and
that's great.
But on this one, it says
we
you want
have
to
that
look to see how many samples or groups are there? If there's just 1 sample, 2 samples, or 3 samples plus. And then it says to look for, is the standard deviation of the population known or unknown?
The population, yeah. And in this case, is unknown. Yeah,
Right.
Unknown. We don't have population here.
We don't have that.
you're right.
We don't have
So-
people here.
The standard deviation has to be for not the sample size.
For the population, not the sample.
Yes.
Okay. So it's just unknown.
Yeah, it's
So in other words, okay. So the standard deviation is information is something we cannot determine with just because we're not looking at the standard deviation of the samples, but rather of the population.
Right. We
Okay.
could get the standard deviation of the sample, but we don't know what the standard deviation of the population is.
That's fantastic.
Mhm.
Okay. No, you're right. Okay. So we're gonna go with
and when we have the standard deviation or the mean sample mean, we're trying to get close to the population mean, but we don't have it. Okay, we choose number 1. If this is wrong, it will be
You can shoot me.
Tiffany.
so here real quick.
Paul.
I went to the announcements and it says you're allowed to use the following tools for the test: the normal probability applet, the quantitative inference and quantitative descriptive statistics, and the testing means flowchart. It doesn't give me the link to the testing means flowchart.
So if you scroll down and he gives it like a couple of
Oh, okay. I have to show all announcements.
before
Okay.
that. He like sent it to us a couple of.
Scroll down.
There it is. Okay. It's down in numbers in week 7. Okay. I'm gonna, oh, it's perfect. Okay. Go ahead and never mind. I'm gonna print it real quick. Sorry, I'm just gonna print this so I have it. Okay, that was number 18.
Okay, 19. So which of the following is 95% confidence interval for this analysis? Input your answers for the margin of error, lower bound and upper bound. Determine margin of error for this 95% confidence interval.
We have to make some calculations, don't we?
We put it in the one sample t-test.
One sample t-test
One
and
sample.
the quantitative difference, right?
And we're doing a 95% confidence level, right?
That's descriptive, right? Not inference.
Inference.
Dang it.
No, inference.
Inference. Yes. This is T because we don't know the standard deviation for the population, so we're using a t-test.
Do we know the mean?
What is the null hypothesis?
Okay.
Well, what are they asking?
Margin of error.
They are asking the margin of error.
Error.
Now you're Spanglicizing it.
Error.
This is error.
Mm-hmm. Okay. So determine the margin of error. That would be
So,
margin of error equals
1.96 times the standard deviation. divided by square root of n
So we're looking for what?
for margin
Margin
of
of
error. Margin of
Okay,
error.
so
Margin of error.
not the right one.
Okay, so the margin of error is the difference between the mean and the lower bound and upper bound of the confidence intervals, right?
Right.
So if you take the mean,
Yeah.
which is 13.193, and subtract
13?
11.168, which is the lower bound.
Okay, I need this information because I would put the formula and calculate it, but I need your information, please. What did you just say?
Nothing. Okay,
Before,
so I did this. Okay,
You did it with a one sample t-test, right?
you ready? Yes. One
Yeah.
sample t-test. If you enter in all of the values, it gives you the upper bound and lower bound confidence intervals, right? Of the confidence intervals.
Did you get 11 point?
okay. If you take the
0.024.
Huh?
if you take the upper confidence minus the mean,
Yes,
you have. Okay,
Yes.
good.
that's it.
This is smart
Now-
decision.
Yeah, that's
For
right.
the mean, did you get 13.193?
Yes.
Okay.
I have all my candy from.
Oh, you're eating Halloween candy?
No, I didn't take most of my kids' candy. Why would you say that?
I said, are you eating Halloween candy?
I was kidding. Yes, all my kids.
So did
Okay.
you get 2.025?
2.024. I have 24.
245.
2.5.
It's 245. So you round up. 2.025.
No, my calculator just gave me 2024.
No, you need to
Oh.
be leaving Greg.
This one, I have this one. Look.
Well,
2.025 I got in Excel.
this is what I got on my phone.
Wow, what a phone is that?
I have to break my phone. Like,
Well, it's because yours is a Brazilian phone, and we all know how we can't trust those.
do you know about the politics in Brazil? We can't trust anything here.
Same as in Mexico. Same as in every country.
Okay, United States will get there. Okay, no, it
Nope.
won't. Okay.
Okay, so it was 2.025, right?
2.025. Okay, I will put
The lower
2.5.
bound, it was 11 something.
The low bound is there.
Yep, 11.168.
1.68.
11 point what?
168.
168.
15.217.
Upper bound. Oh, this is just to give us some points, isn't it?
Yep, that's why it's only half a point.
Okie dokie. Great, we have 15 more questions.
15 more.
Only 15 left? Sweet. Okay,
15 left.
I think it's Tiffany's turn.
Okay. Use the following information for the next 3 questions. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. The data are recorded in used Hummer, New York, and LA. We want
give me a
to
second.
know if there is a difference.
Someone is knocking my door, so I'm gonna run and I'm gonna be back 2 minutes.
So we'll just
Okay.
wait here then.
We want to know if there's a difference in mean listing prices between Hummers for sale in LA, group 1, and Hummers for sale in New York. Group 2, create a 95% confidence interval for the true difference of means listing prices between the two cities.
Okay, this is we're doing a difference. Confidence interval for the mean of differences using independent samples.
But my data here are like messed up. I have H3, then H2, then H1.
Okay, those are the models. Don't worry about it.
Ah, okay.
It doesn't specify. Was it your home teachers? Was it the missionaries?
No, it was a package for me.
Oh, nice. Okay. So
Let's keep in.
So are we in 2, or did you get to 30?
no, so you look at the model. The model says H3, H2, H1. I don't
We're
think.
looking at prices only in LA and New York.
I don't. Hold on a sec. Where?
It's confused. It's a bit confused.
Oh, no. Okay, so LA is first, and then New York is second. So
we have two datas here. Okay,
Mhm.
2 samples.
yeah, and they're separated in between 109 and 110. Well, I said that's where they. So it's the confidence interval for difference of means using independent samples. There's no relationship between the dealerships between anything. Okay, am I right there? Do you guys have any agreement or disagreement?
Edgar?
I have insufficient evidence to disagree.
Well, the only relationship would be, it would say like the same company of dealership in LA and the same company in New York. That's the only way that it would be related, right?
They're independent.
Yeah.
Yeah.
Okay, we agree.
Okay, so they're independent. There's no relationship between them. It's just the cars.
Except Edgar, he doesn't accept that.
No, I agree.
Do you agree?
So it's number 3, right? It's number 3.
Yeah.
And if you look at it, there's more in LA than there is in New York. So what does that tell you?
Okay.
They're not paired.
Oh, I was trying to think like because people in LA don't like the traffic, so they were selling theirs. I thought that's what you were trying to infer. Confidence. Okay. Number 23. Okay, let's go ahead and enter this information.
Wait. We have to make sure that we've got the right, if we're looking at this thing correctly, right? We have to make sure that is it not equal to or greater than or less than?
What?
The hypothesis.
Type of test. What are we looking for? Are we looking for a difference, or are we looking for one is greater than the other?
True difference of mean. That's just not equal to.
So not equal to. Okay, so we're good.
Yeah. You agree with that?
Use it, Homers. Homer, is it the car? Homer? See?
It's a car, yeah.
Yep.
Okay.
It's a very, very big, silly car.
Are we in question 23?
Oh, hold on. Shoot.
Question 22.
So which two? It looks to the true difference in mean listing. Okay, now let's ask this: when they are related, and we want to know less than or greater than, that's when it's important which column they go into. But in this example, they only want to know the true difference in mean. It doesn't matter what column they're in because it's a two-tailed test.
But it tells you in this, it says LA Group 1 Hummers for sale, and New York Group 2. So it's telling you
Oh, you're
where
right. It did do that. Okay, that's right. Okay, I didn't read that. Okay, you're right. You're right. Okay, well, good, because that's what I put anyways.
Hummer model price, seller type, body
This
color.
Crazy.
create a 95 confidence interval for the true difference of means listing price between the two cities.
So are we using the paired sample t-test or two sample t-test?
It's not paired. It's not paired because they're not related.
Two sample t-test?
Two sample.
Yep, independent samples, because there's two different amounts too.
Oh, okay.
So just because we can, this is what they look like.
What? Oh, yeah.
So
I
this
know.
is the truck. This is like the original H1 was really big. It's like here. It's right here, really big. And then there came the H2, which is like this. Then the H3, which is like this. It's a lot smaller. So either way,
Which one you have?
yeah,
And which one do you have?
I have.
Everyone has cars like that in the United States.
No,
Yeah.
yes, every single person.
Everybody. I
Um,
drive a big
this
car
is
like
what
that.
this is what I have, but it's a different color.
Here, if
And
you
there's no
have
snow.
a bicycle, you are a lucky guy.
Is that an Altima?
Yeah, it's a company car.
No.
Yeah,
I drive
it's
a Chevy.
Bonito.
I have 105,000 miles on it, and it's time for a new car. Well, what I mean is, it's a company car, so they're going to get rid of it because they don't want to pay for any breakdowns or whatever. So, okay. So then we're looking at this, and it is a not greater than. It is a not equal to. What else here? It is.
So it just wants the upper and lower bounds, which is on the thing.
Do you have that? Okay.
Negative 423.238
Okay, so
is
the
lower.
lower bound, yep, that's what I got. Negative 423.238. And the upper bound,
5417.336.
can you do a screen share? Do you guys need a screen share for that?
Okay, I have to
You want me to share my screen?
Please.
Okay, for this one, I got here really late, and I will just trust in you for this time.
Okay, so
Like 11 documents open and my Excel sheet is super slow.
okay, so I put it into the two sample t-test for means.
Okay, I
LA is
believe.
here and New York is here. See, you can see that New York is there's fewer. There's only this many.
Okay.
That's why I know it's going to be independent, because if it was paired, there would be exactly the same amount.
Right, because they have to be.
Right. And it's not equal to, and then.
Okay, minus 423.
Yep.
Point. I have to use glasses to see.
238.
238. Okay, 238.
You want me to make it really big?
Yeah, I'm getting old.
You can do it.
Yeah, now it's
You see it now?
5417 point. No, it's not. It's point, no?
Yeah,
Point
0.336.
Okay. Thank you, Tiffany.
Uh-huh.
Thank you. Okay. I don't know why, but it's not saving my answers.
Oh,
Oh,
did you
okay.
time out?
I have. Yeah, I have to save mine. So, okay, let me save all.
Great. We'll just wait here
Save all.
Or maybe the internet's super slow or something.
Okay, I saved all one time.
then. Okay.
Thank
Okay,
you.
number 25. 25.
Oh, no.
Question. Wait.
Exercise bone density.
Okay, to someone, just whoever.
Okay. I'm gonna read it. Are we in 25? Yeah, 25. Ah, it's too long.
We have bone density here.
Okay.
Let me open bone density.
I hope this problem doesn't contain the word poultry,
Poultry.
poultry, or shafts.
Or
Okay.
jobs.
Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses exercise stresses the bones, and this causes them to get stronger. One study examined
Examined.
the effect of jumping on the bone density of growing rats. There were three groups. Rats were selected at random for the three groups. A control with no jumping, a low jump group. The jump height was 30 centimeters, and a high jump group, 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats expressed in don't know what centimeters cúbicos was measured. The data
Huge.
reported. And do you have the document? Exercise bone. Okay.
Yeah, we have there. Okay.
Researchers would like to determine if the mean levels of bone density are different between the three different groups of rats listed above.
I propose that this is an ANOVA test.
Yeah, really smart guy. We have more than two, no?
Son tres grupos. Son.
Yeah, that's great.
Okay.
Hey, quit making
Good.
fun of me.
So there are three groups. Yes, I don't know about more than two.
Well, I only
More
say
than
that because, yeah. Low jump.
The t-test.
No, on an ANOVA, do we need all the groups to be the same size?
No.
Okay,
No.
well, they are. So okay.
We just need the variance to be close to equal. Come on.
Jump.
Yeah, I just don't like how big the cells are. I can't have the same all of it in one screen unless I change it. Okay, so
Bone mineral data. No data.
Let me do the high jump.
We need to compute a QQ plots.
so we need to arrange all these in order then.
Depends on the question. If the question asks, we need.
Sort. Well, so artist.
Oh, they want us to get the test statistic.
Just the statistics.
Okay.
7.978.
What's
How do you get that? How
497?
do you get the T? What? How did you do that again? I'm totally.
I
Sorry,
punched it into the spreadsheet,
I
and it
got-
gives
Quantity
Oh,
influence.
it's the F value with the test. Sorry, I was looking for the T square. Okay. Okay, so it is an ANOVA. That is number 25. Test statistic 7.978.
7.978. This is
Yep.
the right answer, okay?
7.7. 7.7. 7.7.
7.97.
9.
Yeah.
Yep.
7.978, and the p-value is 0.0018.
Wait, are you using the ANOVA spreadsheet?
Yep,
ANOVA.
ANOVA.
It's
ANOVA.
the same that we were using.
I'm using the same thing, but I got 7.718.
Check
Maybe
your
the
numbers.
data-
You may
yeah,
have
maybe.
got one of the numbers mixed up when you copied and
Yeah.
pasted. Just check.
I did this last week. Not, it was this week, like on Tuesday, I did the same thing. Okay, the p-value is, just to make sure, point. Okay, the p-value is 0.002.
That's what I got.
Okay.
I don't know what's happening with my thing.
Nothing.
0.0.
You want to share it? We'll see.
No te agüites.
So what did you get for the t-test, the test statistic?
All right. We got 7.978. It's the F score.
0.97.
8. Okay.
Now,
just
hold on.
faster.
But what is the first number? Okay, well, that won't work because did you rearrange yours in order?
I got
No,
the
Okay.
yeah, we don't have to put in order
I know.
right
I
now.
did it just to see if I could do it right.
Okay.
All right.
Cannot.
All right.
Which of the following best express the conclusion of this test? Use a level of significance alpha equal 0.05. We have to use the p-value, and the p-value is less than alpha, and we reject. And there is insufficient evidence to conclude that the mean bond density between all of the groups are different.
there is sufficient.
Insufficient evidence to conclude that the mean bond density of at least one of the groups is different from the mean bond density of at least one of the other groups. This is what do you
It
choose?
is. There is sufficient evidence to say that at least one mean differs from or distant. Oh wait a minute. What? One more. One or
Okay.
more of the means is different than the others.
Why is not the third one? There is insufficient evidence to conclude that the mean bond density
Because we're rejecting the null.
We are
The value
rejecting.
is less than the level of significance, so we reject.
We're going to reject the null.
So I
When
think
we reject,
before there is
when
sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density.
So we reject the null.
Yes.
Okay. We reject because there is sufficient evidence to conclude. This is the last one.
Yes.
There is sufficient evidence to conclude that the mean bone density of all three groups is about the same, because we. Wait, you said the number 4 or number 3?
4, I think.
Okay, but
Wait,
when,
did you say 3 or 4?
Okay, we
4.
know that we have sufficient evidence, so it's either number 1 or number 4.
Oh, okay. I was looking and I didn't realize there were 5. So, okay.
Oh, there is 5.
Yeah, that's why. So the fourth is there is sufficient evidence to conclude that the mean bone density, and the last one says there's sufficient evidence to conclude that the mean bone density of all three groups is about the same.
No.
So.
But I think this is at least one of the groups, right?
Right.
So number 4.
Thank you for that clarification.
Number 4, sorry.
Number 4.
You want me to read the next one? Is everybody ready?
Please, because it's too long.
Okay.
Do it. Please.
Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on the flight do not sell well, the airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of airline tickets purchased 90 days in advance of scheduled flight compared to the tickets purchased only 14 days in advance. Data were collected on costs of one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest purchased ticket price of a one-way flight from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then 14 days in advance. The data is recorded in direct flight cost. Perform a hypothesis test to determine if there is a difference in the mean cost of nonstop flight just 14 days in advance compared to 90 days in advance. Use a level of significance alpha equals 0.10 for the next 4 questions. Do 14 days to 90 days for the analysis.
Are they paired?
Yes.
Yeah, so they are dependent.
Right.
Dependent samples test.
Because they're going to the same locations, right? But it looks like Heathrow, Berlin, on row 13.
Yeah.
Nothing, as if 90 days out there were no tickets available for some destinations. Just like it says, okay, totally.
So if we have the data.
Okay, so this is a paired t-test. Am I right?
Yep.
Paired t-test. Bam, bam, bam. Okay. So, hacemos lo siguiente. Copy and
Paired t-test.
And one more time. Copy Now, let's determine here. There's a difference in the mean cost. So it is a two-tailed test, the null hypothesis, and the level of significance is 0.10. So the confidence level is 0.90.
Not all my things are working. That's weird.
What?
So paired
What did you say?
sample t-test.
Oh, I think I did it wrong. Do you guys have, did you put the 90 days in column 1 or in column 2?
Because
I put 14 days in the column 1.
I put 14 days in column 1. They said,
Oh,
It says do 14 minus 90 days. So I want to put 90 days in column 1. Does anybody else
90
agree?
days.
the difference it won't make a difference because we're just determining if there is a difference. Would it like well, hold on? Would it make a difference though?
It does make a difference. It'll make a difference for the
You're right for the
intervals.
Yes, you're right. It would. Okay.
Okay. So I
let's
change
look.
it, and I have 14 days in column 2, 9 days in column 1.
That's what you think is okay. And so what's the first amount in the 90 days? 202.09.
234.19.
Okay.
234.19.
234.19. Okay.
Yeah, I just want to copy something here.
So for the t-test, I got minus 1.685.
$234.19, right? Copy.
Okay.
Okay.
I didn't understand about this 90 days and
Oh crap. Okay, that's why I can't do that. Need to delete.
I'm not in the same page. I know that this is normal, but
So the first column was 90, second column 14. That's what we're saying, right?
Yeah.
Okay, very good.
okay. What are you doing? I can't understand right now.
Okay, so the first column, variable 1, is the 90-day. So the ticket price 90 days before the flight. Variable 2 is the ticket price 14 days before the flight.
14 days. Mm-hmm.
Okay. So
do we have a 95% level of confidence level, right?
90.
It's 90. 90. Oh. If you look at, because alpha is 0.10. The level of significance is 0.10.
Oh, okay. Not equal to, okay. If you go 0.095 for the p-value,
What?
I have 0.095.
p-value,
What is
right?
the correct? It's a paired sample t-test, which is a dependent sample, right? Number 29. You guys get that for number 29?
29 dependent samples.
That's what I thought. Yeah.
Yeah, last one.
Okay, if you round that P, oh, never mind. It'd be 0.096, right?
The test statistic.
96?
Okay, so the t-score, the test
Oh,
statistic, I have negative 1.685.
That's what I have too.
5. Yes, me too.
Okay.
I don't have this because I didn't understand this part.
Okay. What did you do, Herman?
I put the data, all the data in the paired sample t-test for means.
Uh-huh.
I put all the data there, like for column variable 1 and variable 2.
Okay.
And yeah.
So can you see the t-test there in the last box where it says paired sample t-test?
Yeah, the t-test is 6.409.
6?
So what's your first number on the variable 1 column, Herman?
38,000.
8.
38.
You have the numbers. I don't think you have the right numbers because it should be 234.19. You're using the information from direct flight costs?
Direct flight cost. Let me see
You
here.
guys, I gotta go to the bathroom. Give me a minute or two, okay?
Okay.
Okay. Good luck.
Yeah, thanks.
I hope everything comes out okay.
Okay. I will open again this direct one.
Okay.
And
The first
see.
value in the variable 1 should be 234.19.
Okay, I'm opening this again and see. Okay. Yeah, it's 202, no? Okay. I think I use
Oh, well, in
this
variable
that.
1, you should put the information from the 19 days column. And in variable 2, you should put the info from column C with the data.
Okay. Oh, I should
You know what I mean?
start by 19 days.
Yes. Starting with 90 days and then 14 days.
What will be the 19 days? Will be 122,227.
No, the first is 234.19. Okay, I'm gonna share my screen. Okay, can you see my screen?
Edgar. Okay. I can see.
Okay, so this is the column C is the 14 days data. So you should copy this, all these things, and bring the paired sample t-test to to the variable 2. Aquí.
The second column.
To the second column?
Uh-huh.
Yep.
Yes.
Okay.
And then you gotta copy the
other one to the first column.
To the first one, yes.
Okay. Okay.
And I don't know if you can see my numbers in this box.
Okay, I'm copying.
My
Just a minute.
0.685 and the p-value 0.095, but rounded to.
I'm copying the second column.
Number, yeah, 0.096.
Okay, I still have problems here, but I understood.
So just a thought or question. I know I said this was paired, but does the one flight have anything to do with the other flight? They can be completely different airlines, couldn't they?
Yes, that was what I thought, but it's supposed. Well, I think it's dependent because if the destination the same day, the same time. So, but you are right. It could be a different airline, and everything could change with that. So
what do we got here?
So I'm just questioning my thought is if this is supposed to be paired or if it's supposed to be independent.
It's questioning us.
Oh, it doesn't say that she checked the exact same, but it is the same airport.
It's the same airport to same destination, but it could be different airlines. Already a destination in Europe. Various destinations.
Thank you, Edgar.
you're welcome.
Scheduled flight 98.
What is the p value, Edgar?
The p-value is 0.096.
Okay, 0.096.
Yes.
Okay, I have to participate here. Let me see this. Okay. This information you are looking for is important to know if it's paired or no.
Yeah.
Yeah.
Oh.
I want to say I had this question before on a test and I got it wrong because I thought it was paired and it's not.
Really? I remember the question in the previous test, but I don't remember what I said.
And I want to say that it changes a few of the answers. I think it changes the test statistic and the
P-value? No.
it might.
Okay.
Oh, this is the last one right here, huh?
But they told.
Maybe it's not dependent because a dependent sample needs to well, but we have other problems in the course where the samples were taken from different people. For example, the I think it was a problem about the pregnant.
The pregnant one, the only reason that was wrong was because there was only one sample, and we were saying there were two because we were thinking mothers and babies, but they were only doing birth weight of the baby, so it was only one. It wasn't paired.
So it does one depend on the other. Are they doing the exact same location but different flights, or different airlines, or same airlines? They're different airlines.
They're doing completely different airlines. It doesn't say. That's what I'm saying.
So it's just. You open it a little bit bigger. It doesn't even have the name of the airlines. It's just the airport. So let's see. Let me read the comments here. It says, "These data represent the lowest published airfare for one-way nonstop." So it's only lowest. So Heathrow to various destinations across Europe. For example, for each airport, the prices presented for a flight booked 14 days in advance. Not available from the information. Well, that's a really good. You know what? I think you might be right. I think this might not be related. Oh boy, man, making us think and stuff.
I know, like seriously?
I don't think they're related because it would have to be the same on or something. Yeah, I'm with you. So the two sample t-test then, huh? Because the paired sample. Well, hold on, but the paired sample, the two sample doesn't have the differences, does it? Like there's different information given.
It doesn't have the differences, but it compares one to the other. Oh, it doesn't. No, it just, is it asking for that?
Well, I guess.
I think this is paired.
Okay, let's do paired. Herman said it's paired. I trust him.
Okay. All right, so then the last one would be, which of the following best expresses the conclusion using a significance level of 0.10, low significance? Because it didn't ask us for confidence intervals, just p-value and test statistic. So this is always the part that I have the hardest with.
I think it's the second one. There is sufficient, well, based on the numbers that we got, there is sufficient evidence to conclude that there is a difference in the mean cost, right? Because the p-value was
the p-value is less than. Okay.
Yep.
So it's the second.
Well,
yeah,
and that average is negative 24.61. This was a similar the one that was on the test. It's a negative 24.61 is the average difference, is the mean difference. And so what they're saying is, okay, there's enough evidence. Okay.
Okay, and here it's talking about the differences, and probably this is paired.
Compared to the 19 days.
Because the questions here are about the differences.
Okay.
Okay. What did you got in question 8 in the input, the upper bound for question 8?
I got 1001.96.
That's what I got.
1,000 plus 1.96. That was our z-score.
1001.9.
1001.96. Yeah. Did anyone
Okay.
submit the quiz yet?
Oh, did you finish all the questions?
Yeah, we're on number 32 right now.
I didn't
No,
submit and I got one wrong.
Okay, I
So what-
didn't do number 25. What do you have, number 25?
$25, ANOVA.
ANOVA? And the number 29.
29, it is a dependent sample. So it is this dependent sample test, the last one, which is number 5. So which one did we get wrong?
30.
Really?
Yep.
But
But
the
we're
people-
right, it's a dependent sample.
And the p-value is 0.096. How would the test statistic be wrong?
Number 30. So number 29 was right, dependent sample test.
And so, are you sure? Well, I guess you can look and see what your answer was, right?
Change the type of the test. Is it not equal to or greater than or less than?
That only changes the p-value.
Value?
That only changes the
Yeah.
p-value.
Only change the value?
No.
Yeah.
And then,
Should we round the
I bet you it's a positive number and I put negative.
No, it's negative 1.685.
Take
It's
the negative out.
1.685.
Yes, that's what we got.
That's
What
wrong.
How is that?
What's
The
the
difference
last
in-
question?
why is it
32,
wrong?
What do you have? Number 32. Edgar, what do you have, number 32? Number 32.
32, let's see. The second one. There is
It's
a
number 2. Okay, I'm going to try it with a positive, but why would we do positive?
The first one?
If you change the two things around, I think it changes that number.
Okay. I put positive because it's kept it there. Submit quiz.
Number 32, what do you have?
the second.
Second one.
The second? There is insufficient.
Oh my gosh, I got number 22 wrong. What did you put for 22?
22.
Confidence level is known.
22. Confidence interval for the difference of using independent samples. The third one.
The third one.
Yes. Herman, what did you got in number 6?
Okay, let me find it. Number 6.
Yeah, you were right. It's not negative. The
six,
test statistic is not negative.
What?
1.96.
Oh, okay. Okay. The t-test statistic, let's see if we change the confidence level. No, nothing happens if we change the confidence level. Nothing happens if we...
Yep, if you do the 14 days in column 1 and then the 90 days in column 2, I get a t-score of 1.685, not a negative.
Okay, tell me what you just said.
I
If you
put
take the-
the 14-day
You
First-
just switch.
in column 1
okay,
and
Yeah.
the 90-day in column 2 instead of the other way around.
but it doesn't tell us to do that though, right?
It does say, I think it says 90 or 14 minus 90.
And we went all the way out of our way to do 90 minus 14. Okay.
Yeah, because it's at the very end, it says for the next 4 questions, do 14 days minus 90 days for the analysis. 14 days to
Okay.
90 days.
Oh, okay.
So I think they're telling us to do the 14 days first and then the 90 days. And I did it the other way around, so I got wrong.
How many points is this test? 30 points. Hey, we got 29 out of 30. That's good. The actual test is 60 points, right?
I don't
think it
know.
is.
Hey,
What-
isn't
what's-
there a study session right now?
Oh, going on with him? Oh gosh, I have no idea.
No, with our TA.
Oh, I don't know.
I am submitting.
Okay. Is everybody else good?
Yeah,
Let me see.
I'm just making a study sheet by.
Well, I think that wasn't the problem because I used the other. You is wrong.
Shoot, what did I put for number 3? Yes.
I got 100%.
Hey,
No.
good.
Wait,
Are you kidding me?
What answer do you want?
Number 30.
Okay, it's positive. The same number, but positive.
Oh, really?
1.685.
Yeah, 1.685.
Okay, guys, well, I gotta go. I'm gonna jump off and see if I can jump back onto the study group.
Okay. Do you guys want to try to meet, or are you too busy?
I can do that if you guys want to.
When?
If I have time, I'll send it in a group email. I don't know. My wife just got called to be Relief Society president, and things are crazy right now. 2 people in the ward just found out they have cancer, like all this crazy stuff. 2 women in the ward, it's nuts.
But
So I don't know.
we
They
did very good job.
reply if we meet.
What?
What do you think? We did very good job today.
We
Yeah.
did.
We all participated, even I.
Yep.
That's
Good
okay.
luck in the
Thank you.